Hello everyone, my name is Ruixiao Zheng from the School of Design at Hunan University. I'm here to present our work, Waves Push Me to Slumberland, Reducing Pre-Sleep Stress Through Spatio-Temporal Tactile Displaying of Music. Previous research on the tactile displaying of music focused on developing a better method for conveying music emotions through haptic channel. Music is considered as the source signal, while tactile content hasn't been investigated much in depth. The main application of this technology is related to music, such as music listening, music education, and live music performance. From the knowledge of psychology, we know that strong and negative emotions, such as distress, tend to reduce the quality of sleep, while the opposite for positive emotions. Since music is an effective tool for emotion management and sleep assistance, we wondered if this technology would be effective on reducing stress in the pre-sleep context. To start our work from the perspective of composing haptic content, we reviewed related work and identified four kinds of spatial temporal vibration patterns, which have been showing the potential to evoke diverse emotional states. These patterns are directional patterns, crawling patterns, alternative patterns, metaphorical patterns. Based on these research backgrounds, we propose three research questions on the stress reduction effects of the spatial temporal tactile displaying of music and the underlying mechanism or human factors contributing to these effects. The main elements of our research work and research contributions are shown in this framework. At the beginning of tactile content design, we introduced some spatial temporal parameters to define different patterns, such as the duration of a single motor, spatial trajectory, essential, and we employed 12 transducers to form a tactile display interface that covered the whole body to provide a more immersive somatic sensation. According to the four types we identified, we conceived 16 vibration patterns. Directional patterns follow a simple trajectory in a single direction. Rolling patterns are more flexible and dynamic in spatial motions. Alternative patterns involve bilaterally alternating vibrations produced by pairs of symmetrical motors. Metaphorical patterns generate sensations that represent natural phenomena, physiological rhythms, or social behaviors. Then, we made an audio-tactile display device that was able to transform the music signal into perceptible vibration and present these spatial temporal patterns. In this prototype, the music signal was converted into vibration through a 10th order Butterworth low-pass filter in max MSP. Then, the filtered signal will be transferred into an Arduino control circuit, which determines the on or off state of channels that corresponded to 12 transducers. Ultimately, the users would encounter a multisensory experience with the harmonious combination of the repeated vibration loop and music. To reveal the answers to our research questions, we conducted a controlled user experiment within 4 groups, which included 4 patterns and a control condition with no intervention. Our experimental space is a room that is set up like a typical bedroom, complete with a bed that our device is placed on. The experimental procedure involved 3 stages. At stage 1, participants were required to report baseline emotions and informed of being in a situation where they were ready for sleep. Stage 2 contains 5 identical trials that corresponded to the 4 patterns and the control conditions of each group. At the beginning of each trial, participants were instructed to watch an emotionally but intense music video to trigger stress. Subjects' emotional states were assessed before and after the intervention using the visual analog scale for stress and the self-assessment mannequin for arousal and valence. Stage 3 was a user interview with 4 open-ended questions. Consequently, we obtained 3 sets of data for stress, arousal, and valence, and subjective description under each condition. For quantitative data, we made comparisons between the pre- and post-intervention scores. The results showed that most of these patterns, as well as the control conditions, made significant contributions to stress reduction. For stress and arousal scores, a significant decrease occurred after the intervention under all conditions. In terms of balance, we only observed no significant difference in the control condition of Group C, Alter C pattern, and heartbeat pattern. Further, we compared subjects' stress and emotional states after the intervention within each group separately. Special attention was paid to comparisons between the different vibration patterns and the control conditions. And the results, we found that snake, downside, up downside, range off, and alter D pattern are ranked in the first level because they perform much better than the control conditions for all 3 variables. In addition to this, we suggest an experience model consisting of 6 user experience components that were extracted from the user interview. These factors give us a more intuitive description of physical sensations and inner feelings. For example, and the description related to continuity. Patterns with higher continuity tend to calm users' feelings, such as the downside pattern. And the low-pass filter signal was found to provide less continuous waves when there were rich melodic variations in the music. Besides, we found that some tactile parameters like the arrangement and the size of transducers were always overlooked in the study of apparent tactile motion. Finally, we propose 3 design strategies for spatial-temporal patterns and the matched methods between music and vibration. Thank you for listening. We are very happy to invite you to read our full paper for more details and insights.